Alright, in this video we're going to convert polar equations to rectangular equations, and we're going to make use of the facts that x squared plus y squared is r squared, and that the tangent of theta is y over x. So example 5, we're going to convert r equals 5 to rectangular equation. So first let's get an idea of what that looks like. So if we go into Desmos, and we can activate the keyboard here. To get the r's, you want to go to ABC, and there's your r. So r equals 5, and we get a circle. So we have a circle where the center is at the origin and the radius is 5. And if we want to, if we click on the little, didn't come in all the way, but if we click on this graph settings button, we can actually toggle between the rectangular grid and the polar grid using this right here. So, but in any event, we want to convert this into rectangular form. So going back, we're going to start with r equals 5. Now, we know that x squared plus y squared is r squared, so if we start with r equals 5, if we square both sides, we'll get r squared equals 25. And then from there, r squared is x squared plus y squared. So a circle whose center is at the origin and has a radius of 5, the rectangular equation for it is x squared plus y squared equals 25. And if we graph that in Desmos, x squared plus y squared equals 25. There we go. So notice it does give us the exact same graph. Now, one thing to note about polar equations is that we have r equals 5. If we would have also started, instead of 5, we would have had negative 5. When we square both sides, when we square negative 5, we get 25. So in addition to r equals 5 representing this circle, r equals negative 5 also represents that circle as well. So again, with polar coordinates, much like with polar equations, much like polar coordinates, we're not necessarily limited to only having one representation. So we could have r equals 5, but we could also have r equals negative 5. Both represent a circle where the center is at the origin and the radius is 5. All right, moving on, part B, theta equals pi over 4. So our angle is pi over 4, or 45 degrees. Now, as of the recording of this video, Desmos, unfortunately, does not allow you to graph polar equations in the form theta equals. They all want something with r equals. So if we try to do that, theta's over here, by the way. If we try to do theta equals, it's going to pop up with this little error message, but even if I complete it, it's still going to tell me that I can't graph theta as a function of anything yet. So that might get fixed in the future. It might not get fixed in the future. I'm not sure. But what we can do instead is, if we have theta equals pi over 4, well, as I said earlier, the tangent of theta is y over x. So if we take the tangent of both sides, we'll get the tangent of theta is equal to the tangent of pi over 4. Now the tangent of pi over 4 is equal to 1. So we have y over x for the tangent of theta and 1 for the tangent of pi over 4. Then if we multiply both sides by x, we get y equals x, or y equals 1x. So our polar form for this equation is just y equals x. And notice that it makes a pi over 4 angle with the positive x-axis, or with the polar axis. In fact, if I switch over to degrees, between halfway between 30 and 60, we have a 45-degree angle here. So although we can't graph it just yet, we can at least take the tangent of both sides, and it'll be a line where the slope of that line is the tangent of this angle. And if you're going on to calculus next year, you'll spend a lot of time talking about tangents and slopes. All right, example 5, r equals 3 cosecant theta. So this one we can graph. So r equals 3 cosecant of theta. And here we have just a horizontal line through what appears to be 3 here. So we just have a horizontal line going through the y coordinate of 3. So if I make this the rectangular grid, it's even easier to see. So our horizontal line going through 3 on the y-axis has the equation y equals 3, or y equals 0x plus 3. So let's see how that comes about from the polar equation. So 3 cosecant of theta, well, cosecant is 1 over sine, so we have r equals 3 times 1 over sine, and if we multiply both sides by sine theta to clear out our fraction, we're going to have r times the sine of theta equals to 3. Well, r times the sine of theta is y, the y coordinate in polar form, so y equals 3, and there we have our equation for our horizontal line through 3 on the y-axis, whose polar form is 3 cosecant theta. All right, finally, part D, r equals -6 cosine theta. Now, if you're thinking to square both sides, the problem with squaring both sides is if we do that, we'll have r squared equals 36 cosine squared theta. And we're not going to get very far with 36 cosine theta. So rather than square both sides to get r squared on the left, instead what we can do is we can raise both sides, or we can multiply both sides by r. By the way, r equals -6 cosine theta. We type that into Desmos here. Notice we get a circle. Center of the circle is at -3, 0, and the radius is 3. And it's opening up to the circles on the left side of the y-axis here. So if we multiply both sides by r, we'll get r squared equals -6r cosine theta. R squared, again, is x squared plus y squared. And r cosine theta is x. So we have x squared plus y squared equals -6x. And if we add 6x to both sides, we get x squared plus 6x plus y squared equals 0. And again, if we want to check to make sure that's right, we can type in x squared plus 6x plus y squared equals 0, and it does match up perfectly with the graph we started with. Alright, so that about does it for this video. Thank you for watching, and